Okay, today we are looking at performing dilations and scale factors. So we'll use a scale factor to perform a dilation. So really dilations is kind of the main emphasis, but you'll see that vocab of a scale factor a lot as well. To start us off, we have like a little bit of a task here. So it says, Brunel has a new job at a copy center, helping people use the photocopy machines. Brunel thinks he knows everything about making photocopies, so he didn't complete his assignment to read the training manual. Mr. and Mrs. Donahue went to enlarge a sketch of their grandfather to be twice as big and centered in the middle. Brunel taped the original image in the middle of the white paper and placed it on the glass of the photocopy machine and inserted the expensive scrapbook paper into the tray, and they set the enlargement to 200%. In the moment this image to the left was produced, the Donahues were very disappointed since Brunel had ruined the paper. Not only was the image off the paper, but they also thought this image is more than twice as big as the original, since 1/4 of Grandpa's picture is taking up as much space as the original. So now let's go ahead and see some questions. They first say to sketch the rest of the large image. So if we actually kind of finished this picture of the grandpa, then you kind of get like the rest of his head here, right? Come down, I'm not an artist, you get his neck, you get kind of his body here, etc. I mean, feel free, you can be as detailed or as not detailed as you want. I think I may leave it a little bit, his little bow tie, but I think I may leave it like that, because I am not the best artist. Okay. I keep drawing more. Well, you get the idea, right? So, as we look at this, you'll notice most of the image is off the paper. So where should have Brunel placed the original image if he wanted it to be centered on the paper? So remember, he placed it in the middle, just like this kind of image is over here, and it went off the paper. So if he had placed it kind of the upper left, I think it then would have gone on the paper, because you'll notice the image did go kind of down to the right. Mr. Donahue complained that the copy was 4 times bigger than the original. What do you think? Did Brunel double the image or quadruple it? What evidence do you have to support to claim it? So I think this is an interesting one. Like, did it actually double or did it quadruple? It doubled in like length and width, right? So you can see, kind of this part of the image that showed up looks the same size as the original image. But we kind of have, if you look at this side length, it's twice that long. And same thing as we sketch the rest of the image, it's twice as big. But what does that do? I think when you look at quadrupling, he's looking at the area is quadruple. Okay. Transforming a figure by shrinking or enlarging it is called a dilation. Based on your thinking about the photocopy that was produced, list all the things you need to pay attention to in dilating an image. So we need to pay attention to how big we want it, right? So the size. How big, or I guess it could be how small, right? Either one. We also need to pay attention to kind of like the position, or like where it's being dilated from. Because remember, having it in the center didn't really produce what we wanted. I think those are 2 key things. Maybe you want to make sure that it's like the same shape / picture as before. So you want to pay attention to what the original is too, etc. If you've got any other ideas, feel free to jot them down there. Okay, so let's go ahead and dive into some thoughts here. It says, which of the following is a dilation of the original image? So we've got our original image here. We want to know which one's a dilation. So out of these different options, A, B, C, or D, the dilation looks like, I think, this first one, right? So it looks like it got slightly larger, but it stayed the same shape and size. You notice this next one kind of turned. So if it turns, that's called a rotation. This next one flips, which is called a reflection. This last one I could see as well. This one didn't change the size, right? It stayed the same size. So it's more likely that they're thinking about that as a translation, because it kind of moves down a little bit. But that's kind of hard to tell. But stay the same shape and size. Okay, so let's talk about what you actually do with dilations. So a dilation is a non-rigid transformation, meaning that it changes the size of a figure. The pre-image and image are similar. Remember our symbol for similar is a little squiggly line. So you can either have two things. You can have what we call usually a reduction, meaning our pre-image, what we start with, and what we go to gets smaller. Or you can have what they call an enlargement, which means the pre-image, what we start with, what we end with, the image gets larger. So a dilation, K, uses what they call a scale factor to reduce or enlarge a figure about a center. So there's got to be some point that we're dilating it from. That's what we call a center. If K is bigger than 1, just think about it. If you multiply by 1.5, or you multiply by 2, or you multiply by 10, then the image will be an enlargement, meaning it will get bigger. If you multiply by something between 0 and 1, so like a half, or 0.2, or 0.9, the image is going to get smaller, so we call that a reduction. If K equals 1, then the image will be congruent. So it's not going to change shape or size, right? It stays same size. Okay. So as we think about the scale factor, it is a ratio. And this ratio I usually think about is the new over the old. You can think about it as the image over the pre-image. So what you start with, what you end with, and what you start with. As we look at the figures to the right, so the triangles, and we're trying to find the scale factor. So first of all, notice they have this A and they have A prime, the little apostrophe next to it. They got B prime with a little apostrophe next to it. This means that we're starting with the figure on the left, that this is the pre-image, and this is the image. That little C prime there is indicating that that's where you end up. So as we want to find the scale factor, sometimes people abbreviate with SF, or sometimes we call it K. We're going to take the image, which choose one side length. Let's say we choose 15. We're going to compare it to the same side on the other one, so 5. So here our scale factor is 3. And it doesn't matter which side you choose. Had I chose the top, which is 12 and 4, you'll notice that 12 divided by 4, as well as 16.5 divided by 5.5, these all equal 3. So our scale factor is 3. Okay, the next one, identify each image either as a reduction or enlargement, then find the scale factor. So, once again, remember you start at P, we're going to P prime. So the fact that we started with the bigger triangle and we went to the smaller one means we have a reduction. As we try to find our scale factor here, they only give us one option, right? We only have one side length that we can compare. But remember, you got to start with the new one, which the new side length here they're saying is 5. And then I guess something else here just to point out, notice they're saying that it's 5 away from the center. That's where it's dilating from. So kind of dilating it out from that point. So 5 over what they say is the larger one, or the old one, the pre-image is 10. which you could say is the same as like a half or 0.5. Which makes sense, right? We said between 0 and 1 will be a reduction. Okay, let's keep going. Find the scale factor, then use it to find the missing sides. So we're going to have to solve for x and y. So we're going to have to use this side. So we've got a 5 and a 12.5. So to find our scale factor, you can either use SF or use K. We're going to do our new side, which is this P prime, which is 12.5, and we're going to divide it by the old, which is the one that has P, which is 5. As you take 12.5 and divide it by 5, you get 2.5, which means our new triangle is 2.5 times as big as the old one. So there's a couple different ways we could do it now, right? I think a lot of kids say, okay, well, if it's 2.5 times as big, if I know x relates to, let me just change my colors real quick here. If I know x relates to 8, I'm just going to say 8, and when I multiply by 2.5 or make it 2.5 times as big, I'll get what x equals. So when you do 2.5 times 8, we end up with 20. Okay, then if I do a similar thing for y, as we take a look at y, we're doing y compared to 4. So doing 4 times 2.5 is 10. So notice there, we've got the three things that it asked for, right? It asked for the missing sides. We've got x and y, and it asked us for a scale factor. Okay. Not the only way we can do it. We're going to start using some ratios in the future, but for right now, I think that will kind of be the thing that makes the most sense to you. Okay, last but not least, we're going to look at dilations on a coordinate grid. So we're going to dilate the scale factor of a half, so it's going to be a reduction, right? We're going to make a smaller triangle with the center at the origin. So we're dilating it from this point right there. Okay, there's two ways to think about this. Think about a dilation as the distance from the origin. So if I think about B is 1, 2, 3, 4 to the right, and up 1, 2, 3, 4, 5, 6, right? So I can think about taking half of each of those distances. So I could say, okay, to find B prime, rather than going 4, I'm going to go half of 4, which is 2. And rather than going up 6, I'm going to go half of 6, which is up 3. And I could call that B prime. Okay, I'm going to practice the same thing for a minute just with C prime. So C prime, we're going down 1, 2, 3, 4. So I could say, well, I'm going to go down half that distance then. So I'm going to go down 2. And that's C prime. So that's one way to think about it. You can think about taking half of the x value and half of the y value. The other way to think about it is, if I draw like a line straight from that point to, sorry, I just drew it a little crooked, straight from that point to the origin, so to our center dilation, you can think about going half the distance on that line. So you'll notice this line kind of goes down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. So I do that like kind of 4 times. So I'm going to do half as many. So like you'll notice kind of the midpoint of this line is right here in the middle. So it's A prime. I've kind of done this like with one of the other ones. So like if we look at B prime, for example, and I connect these, you'll notice halfway through this line is right there at B prime. Okay, so that's 2 different ways you can think about it. At the end of the day, once you draw the points, we are going to connect them. And we get the following triangle, right? Maybe I'll even shade it in a little bit so you can see it because I got a few lines going on there. Okay, so you are expected to be able to draw them. You're also expected to be able to find the points. So just like we talked about with these points, think about you're taking half the x value, half the y value. So you're doing -4 times a half is -2. And then you're doing, sorry, that's a little messy. me see if I can make this a little clearer. So negative 4 times a half, and you're doing 8 times a half. So we get negative 2, and positive 4. Once again, you do the same thing. So 4 times a half is 2, 3 times a half is 3, 0 times a half is still 0, a half times negative 4 is negative 2. So the other way, I guess the third way to think about it is just do it algebraically. If you know the points, then you can just plot them as well. Okay, this next one has us find the scale factor. So I feel like there's two ways you could think about this. I guess there's a couple ways, right? I could think about the points. So like let's think about b for a minute. B is at 1, 2, and b prime is at 4, 8. So you could say to yourself, well, if I take my new over my original, right, my scale factor, just look at the x values, for example. I have 4 over 1, so I get 4. Or you could say to yourself, well, I'm multiplying 1 times what to get 4? I'm multiplying it times 4. The other way to think about it, right, remember how we said, okay, if you drew this line in, notice how this point, our original point, if we scale it from the origin, the center, I should have pointed out, is at the origin. We're always going to keep it there, is 1/4 of the distance to b prime. So this is 1/4 of the way, right? I'm going to go, notice up 2 over 1, but then I go up 2 over 1, up 2 over 1, up 2 over 1. There's 3 more of those, so 1/4 of the distance. So you're making it 4 times as large because we're going this way. We're starting with small, going with big. Okay, what if I asked you, hey, what if the dilation had been a dilation of 3, a scale factor of 3 from the point D? So what if I changed it and I said, okay, rather than, we still started with this original one, what if I made it a dilation of 3? How would that change what we have here? So once again, choose the method you like. If you like kind of going 3 times as far away from the origin, you can do that. You can scale it along this line, up 2 over 1. So we're going to go up 2 over 1, up 2 over 1. We're going to do that 3 times total. Or you could just think about multiplying. I kind of like multiplying the x and y. So if our original x and y is 1, 2, when you multiply by 3, we get 3, 6. If I look at, oh, I put it in the wrong spot. That was b. Okay, if I look at a, I'm at 2, 1. So I multiply that by 3. 2 times 3 is 6. 2 times 3 is 3. And last but not least, this point is at 2, 2. So I multiply that by 3, I get 6, 6. And you could go ahead and draw that in, but I think it's just good for us to see, like, hey, you know, if it's a dilation of 3, it will be a little bit closer to the origin, to our center, but it's going to be slightly smaller as well. Okay, good luck with your assignment.